This is fluid coding and AI. The same developer assistant can now be built two ways: hand a mixed corpus to Gemini File Search or assemble your own retrieval stack. The surprise is not that one wins, it is that each one breaks in a different part of the product. The test case is not a clean folder of Markdown. It is developer reality, docs, PDFs, diagrams, screenshots, source files, old versions, repeated concepts, and answers that need citations. The question is practical. When is the managed API enough, and when do serious developer assistants still need a custom retrieval layer? By the end, you should have a decision rule, not a slogan. Gemini File Search is the managed path. The documented flow is simple: import files, let the service chunk them, embed them, index them, search similar chunks, and feed the retrieved context back into Gemini. That means the boring parts of a first RAG system are no longer your first engineering project. You can create persistent file search stores, attach metadata, use metadata filters, and get grounding metadata back for citations. The important update is multimodal retrieval. Google says File Search can process images and text together through Gemini embedding too. For a developer assistant, that changes the shape of the corpus. A screenshot, a diagram, a PDF page, and a source file can all become retrievable evidence instead of forcing every visual artifact through a fragile caption-only pipeline. File Search can also return page numbers for page-bearing documents and media identifiers for cited image chunks. The custom path is not just use a vector database. It means the application owns the loaders, parsing, OCR, screenshot handling, chunk schema, embedding calls, vector storage, filters, re-ranking, prompt packing, updates, deletes, and evaluation logs. Frameworks like LangChain and LlamaIndex can organize that pipeline. Databases like Chroma, Qdrant, and pgvector can store embeddings and metadata, but the product still owns the retrieval behavior. Take a user asking, where is the button that triggers deploy and what code handles it? File Search has a real advantage here. Native image and text retrieval can bring back the UI screenshot and related docs together. A custom stack wins only if you build the extra links, screenshot regions to routes, test IDs, telemetry events, code symbols, commits, and permissions. That extra context is powerful, but it is not free. Now ask, in the architecture PDF, which service owns webhook retries? File Search can get you grounded answers quickly when the relevant PDF page is retrievable, and page-level citations matter when a developer is about to change a system. Custom retrieval becomes attractive when the diagram needs layout preservation, OCR, graph extraction, or domain-specific parsing. If the answer depends on arrows, boxes, ownership labels, and relationships, naive chunks may flatten the thing you needed most. Source code is the hardest case. A developer asks, what breaks if I change auth session refresh? File Search can retrieve source files as documents, which is useful for context and fast recall. But a serious code assistant often needs more than nearby text. It may need AST references, call graphs, import graphs, tests owners, line ranges, and recent commit history. That is where custom retrieval stops being infrastructure vanity and starts becoming product behavior. The File Search limits are not edge trivia. They shape architecture. The docs list a 100 megabyte maximum file size per document, tiered project store limits, and a recommendation to keep each store under 20 gigabytes for retrieval latency. File Search also cannot currently be combined with Google Search grounding or URL context in the same request, and it is not supported in the live API. For many internal assistants, that is fine. For some products, it defines the boundary. The benchmark evidence is useful, but it has to stay scoped. Google reports strong embedding benchmark results and partner retrieval gains for Gemini embedding 2, including multimodal use cases. The Gemini embedding paper reports high MTEVN and code scores for the experimental lineage. That supports the claim that the embedding model is serious. It does not prove that File Search beats every custom stack or that it will answer your developer assistant's golden questions correctly. Custom retrieval buys control, but it also buys failure modes. With pgvector, exact search gives perfect recall, while approximate indexes trade recall for speed. Qdrant exposes payload filtering, grouping, and query planning. Chroma supports metadata and multimodal retrieval patterns. Those controls are valuable when you need them. They also mean your team owns indexing strategy, filtered search behavior, re-ranking quality, stale chunks, re-embedding, and the logs that explain bad answers. Here is the decision rule. Start with Gemini File Search when you need a prototype, an internal tool, straightforward grounded answers, citations, metadata filters, and native image plus text retrieval without owning the whole pipeline. Build custom retrieval when your requirements demand deterministic parsing, permission isolation, hybrid lexical and vector ranking, re-ranker control, code-aware retrieval, source linking, eval instrumentation, provider portability, or detailed latency and cost tuning. Managed retrieval is the default. Custom retrieval is justified by requirements. The boring RAG stack is being productized. That is good news. It means more teams can build useful developer assistants before they become retrieval infrastructure teams. But the hard part did not disappear. It moved into corpus design, permissions, evaluation, source linking, and workflow integration. Use file search until your product requirements explain why you are building the custom layer. If this comparison helped you decide where managed retrieval ends and custom retrieval begins, like the video and subscribe to Fluid Coding and AI.